and today we're going to talk about planning your very own chaos day at your organization. So just a little bit about me. Who am I? Why am I here? I've been breaking things in production on purpose since 2009, where I started doing it at the National Australia Bank. So back then we called it disaster recovery tests. We had to do it for compliance purposes, right? Because you're a bank, so to keep your license and to be able to actually be a bank, you need to do these disaster recovery tests. And then they get checked by, there's a group in Australia called APRA, who are the ones that check it. So at Gremlin, we also do something called Failure Fridays. So on Fridays, we actually break production. The entire company does it together, which is really cool. I also have done database and cache chaos engineering at Dropbox. I was the SRE manager at Dropbox, leading the databases team, and also Magic Pocket, which is the storage team. And then I also led the dev tools team, which is called Code Workflows. So I led multiple teams there over the last few years. And then I also worked at DigitalOcean, where I would often reproduce incidents that had happened. And DigitalOcean has 13 data centers around the world. It's a cloud infrastructure provider. So yeah, there's a lot of hardware, and you can imagine a lot of things go wrong when you're looking after your own data centers at such a big scale. And I was managing a large team there, a third of the company. And now I'm at Gremlin. I'm really excited to have joined Gremlin, and I'll talk a bit about that too. And also I'm the co-founder of Girl Geek Academy, which is a movement to encourage women to learn technical skills. We're actually trying to help 1 million women by 2025, which is a big goal, but we're actually doing really good. So you can check that out too. And yeah, I'm Australian. You can hear from my accent. And my accent's actually much stronger now because I recently went and lived in Australia and worked remotely for 5 months. I came back so much more Aussie, so I hope everything's all good. So this is Gremlin. Gremlin is basically a platform that has everything you need to do to be able to do your chaos engineering experiments. We have Eugene and Ho Ming who are here up the back. They're going to be here at lunch as well. Happy to answer all of your questions. And yeah, when I first saw Gremlin, I was just like, wow, I have to join the company. Like, that's actually what happened. I got a demo account and I thought it was amazing compared to everything else I'd seen in the past. And that's why I joined. I really loved it. And also we have an amazing team. So our founders are actually, they've done this before at tons of companies, Netflix, Amazon, Salesforce. They built chaos engineering platforms before, and they thought, why not create our own company and focus on doing this and providing it to customers all over the world? So you can actually find them on Twitter. Colton Andrus, he's our CEO. He's also a father of 5. And our CTO is Fawny. He'll be here later today speaking on a panel, so you can ask him questions as well. And our office is actually in San Francisco. We also have an office in San Jose. A lot of people ask me if we have an office in Australia or if we're an Australian company, because I am, but no, we're an American company. So now let's switch gears and start to talk about planning your very own chaos day. What is a chaos day? You might be wondering, what is this? Like, what are we talking about today? So here's a bit of a definition for you. A chaos day is a dedicated team day focused on using chaos engineering to reveal weaknesses in your system. And I always like to define chaos engineering too. So chaos engineering is thoughtful, planned experiments designed to reveal weaknesses in your system. This is our definition from Gremlin, something really short and sharp. You can see here, this is actually the history of chaos engineering as it's evolved over time. So actually, there was quite a lot of chaos engineering happening at Amazon, and that's where Colton and Fawny both worked. That's where they met. And then after that, Netflix had created Simian Army, which is open source. There are a number of tools that you can check out on GitHub. LinkedIn also has a number of different chaos engineering platforms and tools. Uber built UDestroy. Netflix then has Fit, which was actually created by Colton when he was there, our CTO. It's a failure injection platform. Then after that, we actually have Gremlin, founded about 2 years ago, but we only launched in December. So Colton and Fawny were busy hacking away, building Gremlin for 2 years before they actually released it and launched the company. And I joined just at the end of last year. And then Microsoft too has a number of different chaos engineering tools that you can use. And Netflix also recently built Chap, which isn't open source. But yeah, that's what's happened over the years. So who here has a business continuity plan? A few people do, yeah. So if you work at like a very large company, a big enterprise, a bank, you probably have a BCP, which is a business continuity plan. And if you do have one of those, then you'd already be doing experiments in production. You'll call them like disaster recovery tests. Who here has done a disaster recovery test? Yeah, like lots of people, right? So you've already run experiments in production if you've exercised your disaster recovery test. But the problem with disaster recovery tests is usually maybe you do it once a year, once a quarter if you're lucky, but it doesn't really help you so much because it's not continuous. You're not doing it all the time. You're not learning a ton from it because it just doesn't happen frequently enough. The thing is, if you do a disaster recovery test once a year, you know, a lot of people leave the company in that time, a lot of things change, a lot of new systems get built, a lot of code changes. So it's not really this idea of automated continuous chaos that you're injecting and learning more frequently from. So that's why chaos engineering is focused on making these experiments automated and continuous. And there's a lot of inspiration for chaos days. So some of these ideas are game days, capture the flag, hack days, and hack weeks. So just think about those things when you think about chaos day, and I'll explain how they relate. So game days. Who here has heard of game days? A few people, cool. So game days were actually invented at Amazon. Jesse Robbins created the idea of the game day. He used to actually go into the data center and actually like pull out cables, physically pull out cables and machines, turn things off. And that was the idea of the game day back then. So like that's pretty cool and that works. But you know, you can also now build software to do the same thing, which is why we created Gremlin. But you can definitely do a game day, and we do game days with our customers. Eugene and Ho Ming have run tons of game days with people all over the world. And it's a really great day. So you learn a lot. Maybe for 2 hours, you're injecting chaos using chaos engineering experiments, and then you're learning from that as a team. And we've also got a guide, which you can find on the Gremlin community, how to run a game day, which Eugene wrote. Hack days and hack weeks. Who here does those? Oh, a few people, not so many. So hack days are really awesome fun, or hack weeks. This is something that I did a lot of when I was at Dropbox, also at the National Australia Bank and DigitalOcean. The reason that people do hack days or hack weeks is it's meeting free time to just innovate, to think of cool, wild ideas and build something amazing. Pretty much, I think it's around 60 to 70% of Dropbox's biggest innovative products came out of hack weeks. So that's why they've continued to do them every single year. And it's just an amazing fun time. But the idea with a hack week or a hack days, it's really focused on features. You're focused on building new things, building new features that provide value to customers. But it's an engaging time. Everyone just does no meetings. They come together and they build things. They hack away in teams. Capture the flag. Who's heard of this? Cool. So yeah, capture the flag is more of a security type of competition, where you actually learn how to find vulnerabilities, and it takes you through a number of stages. So what you do is, there's actually an open source platform that Facebook has released that you can find on GitHub. And really with these, it's more, you go to this Capture the Flag platform, you create an account, then there are a number of challenges. So you go through like 1, 2, 3, 4, 5, and they get harder and harder, but it's a really great way to learn more about security. And actually when I worked at the National Australia Bank, I was a security engineer for a while there too. And one of the things that we did as security engineers was teach all of the other engineers at the company how to write more secure code, because there are a lot of things that you need to constantly be learning about, since you know, people that you're trying to defend against are always thinking up new ideas and they move pretty fast. So we would teach them about SQL injection and things like that. So why run a chaos day? There are a variety of different benefits for a variety of different people. So here's a diagram that I've slightly modified to explain this. When you want to say, okay, let's do a chaos day, everyone, there are a lot of different types of reactions you're going to find. I like to start with influencers, people who are going to be really on board with this. Then there are the waverers who maybe yes, maybe no, not really sure. Then there are the moaners, people are just like, oh. The opponents, the mutineers, the skeptics, the fanatics, and the passives. So let's talk a bit about them. This is chaos day sociodynamics. So first, let's start with the influencers. Often these are your engineers on call, so they are actually often going to be the ones who are really excited about the idea of doing a chaos day. Topics to expect from them: how to practice chaos engineering. They just want to know how to do it. They're all in, like, let's figure out just how to do this. Another really useful topic to talk about is continuous chaos, how you can automate chaos engineering and just continue to learn from it throughout the years. Waverers. These might be your engineering managers. Maybe, like, they want to do it, maybe they're not sure, but a topic that they're going to ask about is what is chaos engineering? Like, what actually is it? And then a useful topic to talk about would be the cost of downtime. So it's actually really good to ask an engineering manager, do you know how much it's going to cost our business if we're down for 8 hours? Because, for example, British Airways had a 10-hour outage and it cost them £80 million. And often companies don't know how much it costs if they're down for 5 minutes, down for an hour, down for a day. That's a great question. Passives. These might be your engineering directors, VPs, especially like more senior because they're just so busy, right? There's so many things to do, so many things to think about. But they often do want to know about why you should practice chaos engineering. Like, what kind of value is it going to bring? And another really useful topic to talk about is incident and on-call reduction. So you can actually show them the numbers and say, look, this is how many incidents we have right now. This is how many SEVs we have. This is how many SEV zeros we have. And this is an opportunity to actually reduce that. I myself have seen 10x reductions in incidents because of chaos engineering. And within a really short time, like I'm talking 3 months. So that's why I'm such a big fan of engineering. Moaners. These are more like specific individuals. You probably already know who they are in your own company. But they'll say things like, I'm too busy. But a really good topic to talk to them about is, you know, we don't learn by always doing things the way we've always done them. That's often something that people might talk about. It's just an opportunity to learn some new things about your team and about your systems. Opponents. These could be people in different departments or just specific individuals as well, but it could actually be customer support team too, because, you know, they might be really worried. Chaos, what are you doing? Like, why are you trying to cause chaos for our customers? Like, what is going on now? You want to break things? Are you going to make it a really bad experience for people? They're going to be potential opponents. And they might also say, there's already so much chaos. This is something that you commonly hear from opponents. A useful topic to talk to them about is the impact of SEVs and incidents on the business and on teams. So chaos engineering is a way to actually reduce the amount of SEVs and reduce the amount of incidents, but you're going to have to go through an educational process and just open up those communication lines so you can talk to them about it. Fanatics. So fanatics are usually really into something maybe else that they just want to talk to you about instead of talking to you about chaos engineering. So example would be, I believe in unit tests. I love unit tests. Let's just do more unit tests. A useful topic is chaos engineering is unit tests for alerting and monitoring. So often it's just also, again, education. Do we do unit testing for our alerting? Do we do it for our monitoring? Do we even know if our monitoring works? Have we ever tested it? Most companies haven't. And you can imagine this is something that commonly occurs. Say there's an alert, someone gets paged at 2 a.m. They go, oh, that was a bit of a noisy page. They change the threshold and then it's not so good anymore. And now it's not just a noisy page, it's like a useless page. And you're not able to then catch that problem. And there's no checking, there's no monitoring. So nobody even knows that the alert was changed. That happens a lot. Skeptics. We won't get value from this. This is more around defense, protection, and training. And then mutineers, we don't need to do this. You can really give them data on your top 5 most unreliable services, and really just focus on the idea of resilience. Okay, so here are just a few questions to keep thinking about when you're talking to all of these different people. One is, what are their major challenges right now? What will they win or lose by collaborating with you on this chaos day? What is their influence on other stakeholders within your company? And let's talk about a few of the benefits now in detail. So one of them is upskilling your team on building software with failure in mind. Like, who feels like your company does a really great job of upskilling your team on this topic? Yeah, that's cool. Awesome. So yeah, it's not super common, but an interesting thing to think about is everyone in engineering always has a learning budget, and this is real world education. That's what I like to really call it. And when you think about your learning budgets, often they go unspent. Like, this is such a common thing. When I was an engineering manager at Dropbox, I was always like, please spend your learning budget, otherwise it just goes wasted. and you don't even use it. Like, that seems not very good. You could use your learning budget on books, on courses, things like that, but usually it just goes unspent. And often learning budgets can be $1,000 to $10,000 per person per year, which is a lot of money. And I just feel like chaos engineering is a great way to say, let's actually learn together. Gain a deeper understanding of your current system weaknesses. You're definitely going to learn that from chaos engineering. Reduce the severity and frequency of incidents. I've myself seen a 10x reduction, which is pretty massive. And in 3 months too, it's not going to take you a very long time.
Is that common, or is that?
It's super common, yeah. Prevent loss caused by outages. So, you know, we have a lot of problems related to loss, not just cost, but also data. You never want to lose data. There's a lot of things to think about there. People can get burned out, all those types of things. And learn from your failure. This is something we all want to do and we want to encourage. It should be about learning, not just going, okay, we failed, that's not good. We'll punish that issue or that problem, or, you know, we want to actually learn and create this culture of learning. So now let's switch gears and actually talk about how you plan a chaos day, because this is very new for everyone, right? So I thought we'd go into details about how you could actually do it yourself. Yeah, sure.
So chaos day. So when you talk about chaos, that's production only?
I'm going to talk about that, definitely. So how do you plan a chaos day? The first thing is you really want to start early. The goal is to plan, create, and host a very impactful chaos day. You want it to be memorable for the right reasons, right? Your chaos day could be an on-site, an off-site, or a company retreat. So I'm currently actually talking to Cloudflare about doing a chaos day with them as part of their company retreat. They go to Napa every year, which is a really nice thing to do, right? And it's a good opportunity to actually do a chaos day while everyone in the company is together and make it a learning experience. And that fits their company culture. So I'm going to say it's important to give yourself 90 days before you do your very first chaos day. That probably sounds like a lot of time. Who feels like 90 days sounds like a lot of time? Yeah, you're like 90 days, 3 months, that's a long time. But you're like, no, actually 90 days makes sense. That's a good amount of time. So yeah, different people will have different views. Depends on how big your company is and how many people you're going to need to talk to get this up and running. But I think 90 days is a pretty good idea for the very first one. So are you ready for the chaos day? There are a few prerequisites to your chaos day. One of them is that you should know what your top 5 critical systems are. These might be your database, say MySQL, Postgres, your traffic team, what they look after, Nginx, Apache, maybe you have some big data. Think about what your top 5 critical systems are before you start to plan your chaos day. The next one is you need to have monitoring and alerting. A lot of people don't, which is surprising to me until I figured that out. It's like, whoa, when I've been doing these talks. But yeah, a lot of people just don't feel confident in their monitoring. They don't have alerting. They don't have a person that gets paged if something breaks, like say if they go below SLA. It's really important to be monitoring for drops in SLA. I've written a lot about this actually on the Gremlin community, but please come and chat to me at lunch as well if you want to learn more about it. Yep. Yeah, this is like actually a massive problem right now that I've noticed. And there are a lot of tools that you can use. Like I like Datadog, very quick and easy to get started. PagerDuty for alerting, but a lot of people don't have it. Exactly, yeah. Measure the cost of downtime. This is not super common. Put your hand up if you know how much it would cost you if you had an 8-hour outage. Yep, so only a few people, but that's pretty good, 3 people in the room. So the next question to ask yourself is, who will attend your chaos day? What is the focus of your chaos day? How will you measure the success of the day? What is your budget? Where will it be? And now I'm just going to go through a little bit of a timeline. So first thing is, I recommend you create a chaos day crew. This is actually pretty important. Get together a good small group of people to do it with you at about 90 days. Then determine your attendee availability. Really important to do before you start to book stuff in. Like what happens if someone can't make it? That's not good.
Well, then that's chaos right there.
Exactly. Lock in chaos day venue. Find somewhere really great. Send in some placeholder invites to make sure everyone actually shows up at 60 days. Then send out an agenda and also some pre-read information because you're going to have to educate everyone who's coming along so they can learn about chaos engineering. And then boom, chaos day time. So who might be on your chaos day crew? This is really important to get right, so I thought I'd go into a little bit of detail. I actually think it's very important to have someone very senior on this crew. So a VP of engineering, a CTO, or a COO. It's really good to get someone that is an executive because it's good to just get their buy-in and make sure they understand what you're doing before you plan it. Next is an executive assistant. Some of the greatest people you'll ever meet, right? They have amazing skills and they're going to be super handy on your team. An engineering director or manager, someone that's well connected, that knows all of the different teams, that's probably been there a while, that would be helpful. A principal or staff engineer, especially someone who's working on one of those top 5 critical services, that's going to help you a lot. So now let's look at your chaos day crew. I actually think you can use this model. This is pretty helpful if you build a matrix of everyone's responsibilities, who's responsible, who's accountable, who needs to be consulted, and who needs to be informed. So I've just done a little bit of an example here, which you'll find on my slides after this day. So if we have our exec assistant, principal engineer, and engineering leader, let's go through and see this. So who is accountable for it? Who's responsible for it? Who will be informed? Who will be consulted? And I've just gone through here for objectives, budget, attendee list, and availability, venue, invitations and agenda, accoutrements, like making it really cool and memorable, chaos engineering experiments, and extra impact. So you can see here, I'd say good to have the principal engineer accountable for the extra impact, making sure it's really amazing for everybody, and also working closely with the engineering leader on the engineering experiments. But you'll be able to get this afterwards. I think it's good for you to think through the people on your and then determine who needs to do what before you plan it all out. So objectives just for the planning phase, what are they? Make chaos engineering familiar. During this 90 days, you want everyone across the company to know what chaos engineering is before they even get to the chaos day. Identify your key stakeholders, very important that you know who those people are. Create the right story for each of your stakeholders. Chaos day budget. How much will the chaos day cost? This is really up to you, and that's why it's good to have that executive on the team so they can help you make sure you get a really good budget for this day. It could be something where you do it in your office. You don't need to get any special space, don't need to do anything extra fancy. Or if your culture is more that you'd prefer to do an offsite or as part of a company retreat, it might cost a bit more. Attendee availability. There's actually lots of great tools that you can use to just figure out everyone's availability. I like Doodle, it's free, you can see it online. You just send everyone an email and then they all put in their availability. This way you can make sure that everyone who needs to be there will actually be there. They're not on vacation, they don't have meetings, they don't have other commitments. You can find a date that works well for everybody. Chaos Day venue. There's also really great tools you can use like Splacer to find somewhere awesome locally in San Francisco or wherever else you might be. Some placeholder invites. I think this is important to make this a bit fun because you don't want people to book something else over your chaos day. So book the day into your attendees' calendars, but the secret is don't give too much away. Just like say, something is coming. Chaos day is coming. We need you. Be there. Chaos day pre-read information. It's really good to be able to share some pre-read information with your attendees before they get to the chaos day. I've actually created a GitHub repo which has a chaos day pre-read pack. So if you go to github.com/gremlininc/chaos day, then you'll find that pre-read pack. And it's just got a number of small articles. Yep. Yes, you'll definitely get them. Yeah, there's so much info. So yeah, you'll definitely get these slides after this day. Chaos day agenda. What might this look like? So here's just a little bit of an agenda that I've whipped up. So I think it's good to start at 11. You don't want anyone to be, you don't want to start too early. People will be tired. 11's a good time, right? First, we're going to start with some whiteboarding and debate on assumptions. This is something that we commonly do at game days at Gremlin. Eugene and Ho-Ming will do them all the time. But it's really good to do some whiteboarding. Next, we have lunch at midday. Then time for test cases and scoping. So figuring out what the experiments are that you're going to run. Talking to people about the blast radius. It's really important to start small. You don't want to do a really big experiment first. You want to start small and then gradually expand the blast radius. execution, and then recap, review, and get feedback, and close your day at 4 p.m. So pretty small agenda, but that's really what needs to happen during the day to make it awesome. Yeah.
When you go in there, do you think about test cases in advance, or do you discuss
It's definitely good.
together?
It's good to think about them in advance because you'll know your top 5 services, and you can think about a little bit with your crew, and like you can have your principal engineer be involved, think about what experiments might be run, but then it's good to give everyone the opportunity to discuss it too, because you're helping build the muscle that then when they go back to their teams, they start thinking, what experiments might we run? Yeah. What chaos engineering experiments should you perform first? So like I said, really important to determine your top 5 most critical systems because those are good places to start. Then you want to select your target. Say, for example, it could be the database, MySQL. It could be DynamoDB if you use AWS. Stage is okay to start. A lot of people ask this, like, do I have to start in production? No, you can start in stage first. That's totally okay. And then gradually move to production once you're ready. Next, you do whiteboarding. This is something Eugene likes to say. With so many great minds present, it's the perfect time to whiteboard your system's architecture. You know how, like, you know you need to do this, and you know you need to update it, but it never often gets done. So this is a great time to do that whiteboarding. Experiment scoping. And then I'm going to show you a few examples of Gremlin experiments that we have. So we have a number of experiments pre-built. You can run your first experiment within the first 5 minutes of using Gremlin, and they just come out of the box. The way Gremlin works is there's an agent that is on your host or inside a container or a Kubernetes pod, and then you can just run all of those experiments. So let's look at those. We call them attacks, but they are chaos engineering experiments. The first is CPU. So you can do a resource consumption attack, which is consuming CPU resources. Then disk, I/O, memory. So these are our resource attacks. Next one is state. So we start with process killer. So you could, for example, kill MySQL-D. Shutdown an instance. This is similar to what you've probably heard of about Chaos Monkey. Chaos Monkey is all about shutting down an instance. State, time travel. You can change the time of the machine, the clock time. Black hole. This is a networking attack. DNS, latency, and packet loss. So those are all the experiments you can run out of the box with Gremlin. Okay, so we also built this tool called syscheck, which enables you to check that your system can actually run these experiments. I'll just show you that here. Gremlin, syscheck, memory. So it's just checking if it can actually run the memory attack. It's going through. Allocating memory here. And then you'll be able to see if it's successful as well. Doesn't take too long. But this is basically how it works. Gremlin has a command line tool and also a UI and an API. So a lot of customers actually like to roll it into their own tooling. That's how they use the API. For example, Twilio, that's how they've done it. Some people prefer to run it by command line, or they like to use the UI. Yeah. So here are the syscheck defaults. For example, with CPU, we consume up to 1 CPU core on the system. Disk occupy up to 50% of the block device that temp is mounted to. So you can see here the examples. These are just the defaults. But within Gremlin, when you actually go in and say, I want to run a CPU attack, you can choose and specify how you want to run it, which is pretty cool. And this is another thing that Eugene and Ho Ming often use when they're running game days with customers. They like to talk about the blast radius. So for example, if you're doing a latency attack, how much latency are you going to inject and how many hosts are you going to impact? Because then that changes your blast radius. You don't want to go too big at the start, but Eugene will talk about that more later. So now I want to just talk to you a little bit about an example of a chaos engineering experiment, one that we've done ourselves. So our hypothesis is that we're going to talk about, look at latency for DynamoDB. Hypothesis is calls to DynamoDB will time out after 1,500 milliseconds. This will cause elevated 500 status codes in our API. The UI will degrade gracefully, so it's also a good chance to check that that all works. Here's how we run the experiment. So this is what Gremlin looks like when you go into our Gremlin control panel. You can see here We're running the attack for 120 seconds. We're injecting 1,500 milliseconds for latency. And then you can see there impacted DynamoDB. Then you can analyze the results. You can actually see the logs in real time for the experiment. And you can see here, these are the elevated 500 responses for the API. We can see those coming up in our monitoring. We use Datadog. And then you can see here, which I think is really cool, graceful degradation of our UI. We did this on stage, so it's not production. But you can see here, right now you can see all of the attacks on the attacks page, and they're completed, 4,774. You can see here that it says there's an issue loading these attacks, click to retry. But it's a much nicer, graceful degradation instead of just like no page available at all, you can't see anything. That's why we talk about graceful degradation. So people feel more comfortable, customers understand something's gone wrong and they know what's happening, and it would hopefully come back soon, right? But how often do you check that this actually works? The next thing is have an exit plan or an abort plan. We have a halt button. So we have a halt all attacks or a halt a specific experiment button. So we've thought about that when we were building Gremlin. It's very important. And then lastly, recap and review your chaos day. Get everyone's feedback. Make sure that they feel really good about what you did. They learned a lot and they're excited about the next one. And another thing that's important is turn your chaos day experiments into continuous chaos. So you've got everyone together to actually run this experiment. The next thing you can do is you can automate it. You can make it run continuously. We have the ability to schedule experiments within the Gremlin control panel. So if you go in there, you can actually say, I want to run this experiment every week or every day. You can really choose what works for you. But that's much better because you can imagine you've now tested and confirmed that your experiment works as expected. Somebody makes a change, you want to be able to get an alert if something does break or something like that. So that's a good thing to think about, continuous chaos. And this means when you do your next chaos day, you don't have to do this same experiment again. You can think about a new experiment that you want to do.
On a random timer.
Yeah. Yeah. And also establish the chaos crew for your next chaos day. So you'll have a lot of people that were very excited, they came along to your chaos day, now they want to get involved and help plan the next one. So I'd like to talk a bit about this. How do you make it really special and memorable, your accoutrements? Important to always think about food and drinks, like we've got really great food and drinks here, very important. You need to feed everyone. Do you want to theme day hack weeks? They often have themes, so at Dropbox it might be carnival theme or something like that. This is actually from the Dropbox hack week last year, which I was at. There was a giant gumball wizard that was in the office. There was a donut tree with edible donuts. This is a donut just here. You could like go up there and pick a donut out. It's pretty amazing. There was a popcorn machine. So yeah, the theme was carnival theme, and it's just really fun. And the idea behind this is you're creating a lot of enthusiasm, you're creating a lot of energy around the week, and also it becomes something that people look forward to. We did Hack Week at Dropbox twice a year, sometimes even more than that for special occasions. And people actually join Dropbox because they want to go to Hack Week. So it's also a recruiting tool. People talk about it all the time. They love hearing about it. We would often have executive customers come along and they wanted to learn about Hack Week since so much innovation comes out of Hack Week too. So I think about that when you think about planning your chaos day. You also want to make it really amazing. So yeah, carnival theme, pretty cool. One question to ask yourself might be, what are your favorite chaos-filled movies or TV shows? Mine are Outbreak, Gremlins, Mr. Robot. Anyone else want to shout out yours? Yep.
1941.
There you go. So you can think about doing an Outbreak theme for your chaos day. You can imagine a lot of really bright yellow. Maybe you even have someone come in a suit. A lot of monkeys. Mr. Robot, this is also a really good theme. And this is something that actually happens in France too. So when they do chaos days at my friend's company in France, they have themes like this. And they recently did Mr. Robot theme. It worked really well. Everyone was very excited. They had posters in the office leading up to the chaos day to get everyone talking about chaos engineering. You really want to create that energy. Gremlins, you could also do that as a theme. Obviously, I'm a big fan. Love that movie. Extra impact. So one last thing that you could do as well is think about having Chaos Day goodie bags. You could give everyone a book. You could give them some snacks, something like that. So they can just continue to learn after the day. Now we've got 1 day to go till our Chaos Day. Not long left. Last thing you want to do is send some reminders. Make sure everybody shows up. Tell everyone to bring their laptop, very important. Make sure that they actually remember to charge it the night before, things like that. It's something that everyone forgets, but it's really important. 0 days. Welcome to your Chaos Day. Now we're here. That's it. 90 days, and you could be running your very own Chaos Day and make it really, really awesome. So thank you very much. That's this section. Thanks. Alrighty. So now we're going to switch gears and actually do a hands-on interactive exercise. Eugene and I will do this with you. And we'll be here to answer all of your questions as well at lunch. And we'll be walking around too. So something interactive. The first exercise. What should you experiment with on your Chaos Day? So I'll just wait for Eugene to come up here. Do you want to come up here, Eugene? So I just want to introduce you to Eugene. He'll just come up here and tell you who he is. But he's our Director of Customer Success.
Hi, everyone. I'm Eugene. I run customer success at Gremlin. I've been here since late July. And one of the things that really helped me, similar to what Tammy said about Butow, was I got the demo during the beta phase, and I said, this is something that all my customers at AWS. That was my previous life before joining. And having experienced the customer pains and having them not being able to recover gracefully was something that really resonated with me here at Gremlin, and being able to be in a position where I can help them is a really promising thing to do. So that's why I'm really excited to get Gremlin to help everybody else get
Yes, yeah. And Eugene also previously worked at Netflix and Google before Amazon. Cool. So the first thing I want you to think about is, what are your top 5 critical services that you have at your company? And then Eugene's going to talk a little bit about this.
So you're ready to plan your experiment. And a lot of times whenever I talk to my customers, they go, oh, let's just go big, right? I'm going to blow half of my production server. Well, you don't really learn anything from it right from the beginning, right? Because if you blow everything, what do you really learn? You learn that my stuff is going to fail if an entire cluster goes away, right? I mean, you really want to contain that blast radius to something as minimally possible so that you actually learn something. You learn your thresholds a lot more, right? The idea here is to scrape skin without drawing blood, right? I mean, the last thing, especially if you plan to test and prod, is that you don't want any customer impact. So start small. And by that, you could do it in 2 vectors, right? Similar to that chart at first. You could do it limiting the amount of hosts that's serving your service. So 1 instance at a time, doing 100 milliseconds. Or you could start across your entire service, like a whole ASG, and then doing it at like 50 milliseconds at a time, right? Then you slowly dial up the blast radius, right? You could do it again, 1 instance, 1,000 milliseconds. But you never really want to go, my whole cluster, let's just raise it up to 1 million seconds. Delaying your entire packet, all your packets and traffic into next year doesn't really teach you. So that's the concept of just having defined success. It's not literally to break something. To test your threshold and to gain confidence in your system. Now, there's a question about having to test and prod. Right? And honestly, there's that concept that you have to test and prod to get real. But realistically, if your staging environment is representative of your production, you're actually okay getting some data within staging, right? Just be mindful that as you're scoping out your test, even in staging, that it's representative of the scope of the attack, right? For example, if in production you have multi-region, and each region is 3 AZs, and each service spans thousands of instances, right? But then your staging is 1 region, 1 AZ, 1 instance. I said, I'm just going to go ahead and fail 1 instance in there. Well, do you realize that you basically failed your whole service, right? So you might have to scale up your staging environment in order to get that representative, real type of failure mode that you're actually trying to test. So with that, I'll pass it back to Tammy to talk about it, scoping a little bit better.
Cool. So like we said, stage then production, totally okay. But also be careful with stage, because what if people are relying on stage for their day-to-day job? So now we're going to do a fun interactive exercise. In groups of 3 to 5, discuss what your top 5 critical services are. That's where we're going to start first. And if you have like confidentiality issues where you can't share what your top 5 critical services are, you can kind of generalize it a bit. We have a database, like let me tell you more about yours, I can't share. That's totally okay. And we're also going to bring around some whiteboard sheets, which are just around somewhere there. So we'll bring those around for you too for the next part. But the first thing is just to discuss that. What are your top 5 critical services? Often a lot of people haven't thought about this before. Put your hand up if you had thought about this before today. Yeah, not many people. So it's like a really good exercise to do today. Cool, let's do it. Awesome. Yeah, do you know what yours are? So it could be like, for example, yours, if you're at Blue Shield. So what is the most important thing that you provide to your customers? Like, for example, when I was at Dropbox, the storage platform was the most important service. So it's the block storage platform, and we built it in-house. First it was S3, then we built our own called Magic Pocket and moved everything into there. So that would be the service. So it could be database, could be something like if you have Kafka. Yeah, it could be analytics if that's really important to you. That's what I mean by service. Yeah.
You mentioned whole system, but then you mentioned like those are
yeah, and it depends on your company, like, and what you classify as like your service or your system. Some people do like microservices, other people have like big service teams and they don't have that much.
So is the scope here to like consider the entire service?
Well,
because every service will have a database most likely.
It depends on your company though, because not every company's set up like that. Yeah. So like, say if you have like a company with like 1,000 microservices, you might have like 5 key microservices that you want to talk about first, or your company might have just like major services. Like Dropbox only has 8 critical services in total, and then a lot of people just use those services. But yeah, think about more like infrastructure, like heavy usage services. Yeah. Cool. Yeah, network, that's a great one. Yep. Yep, client database, awesome.
You do not have anything?
Awesome, that's great too. Yep.
Things like that. The push notifications.
All right, cool. Yeah, that was great. Awesome. Thank you, Jane. Oops, sorry. All right, cool. Have you got ideas or? Yeah. So, and the thing here is it could depend on your company, it definitely will. If you have, say, for example, microservices, and maybe you have like 1,000 microservices, but you have like 5, which is super critical and everything breaks if they're down or something. Or if your company has just large services like Dropbox, they just have one team that looks after block storage. So obviously that's then a critical service. But so define it based on your own company. Yeah, it's a little hard because it depends on where you work. Yeah, but often, like, usually I like to say, like, you know, it's going to be something traffic related, Nginx, Apache, sort of that sort of service area, database maybe messaging. Yep, you could say that, really broad. It depends, like, you know, at your company, do you have like a small network team? Do they divide into different teams? Is there a more critical part of the network? Yeah. Ooh. Cool. Oh, this is great. This is good. We actually have a lot of time to do this. Awesome.
I like the fact that people
It's
are
great.
talking.
Yeah. Hopefully people will share their services. Oh, that's awesome. Okay, great. Yeah. Oh, yeah, we should do that. Okay. Hey. Cool. Yeah. That's great. Cool. Thanks. Yeah.
So, you're a little bit ahead of time, so if you want to like field questions.
Yeah, yeah.
Or anything
No, I
like that,
totally
just
will be
take-
able to.
take
That'd be
your time.
great.
Take your time.
And I'm going to give them more time to just to work through the exercises as well. Yeah, this is good.
Put in work.
Ah,
You're awesome.
thank you.
You're awesome.
Yeah, thanks. I practiced in it. It was like the same as I practice, but I was faster this time. But I think that's fine.
It's good.
Yeah.
I think that's.
I'd rather be
perfect.
fast and slow. Sometimes I go over and I hate it.
Oh,
Everyone's like,
I talk a lot.
I talk fast.
Yeah.
Everybody's supposed to be like, go down, slow.
I tend to have I use fillers, which is awful.
yeah, I've
I don't
tried
know, I
to.
just,
It,
like,
it
keep on.
happens. It happens. Yeah, it's okay.
But no, that was great. It's a nice. Now,
Yeah.
did you have similar content at like SRECon? Was it similar? Or?
No, my SRE content is totally different.
Good.
It's a full hands-on boot camp for 3 hours. Yeah, it's totally different. It's all
Yeah.
about like breaking Kubernetes,
Mm.
and I give them a Kubernetes cluster, and then they inject experiments.
Awesome.
It's pretty fun. But yeah, it's really cool.
That's badass.
This is actually a fun idea though. Like, I think because when I started to research on it and think about it, it's like, oh, it's kind of like Hack Week or Hack Day.
Yeah, I thought it was good. You know,
That'll be fun.
Yeah.
but you're giving like stuff that's like you can get. There's articles out there about how to start it from a programmatic standpoint, but
Yeah.
I like the way that you've injected make it fun.
Yeah, exactly.
These are like the X factor of something that if it's going to be successful, it's going to
Yeah.
be something that is people enjoy.
And it's one of the hardest things too, I think, when you're in an engineering org, because often like that's what you don't get help for that, right? Like it's really tough. So
Yeah, that's
like,
why
it's
it was
interesting
funny
when you do
said EA,
external
like the EA, the
things. Yeah.
executive assistant. Yeah, I mean, I feel like all those kind of resources, that kind of creative marketing kind of resources, go to like the business side.
Exactly,
and
but they don't help you do things
right?
internally
That's all the
to help you
Yeah.
operate better as a company. Like if
Yeah.
you could have someone from marketing do work on this, it would be amazing.
That's actually a great idea, and it's something that I want to do with like our own engineering team
Yeah.
to keep things fun for them.
You can really help them out. Yeah, and
I mean, a lot of the personalities are more
Yeah.
more introverted
Yeah.
Across the board. I mean, obviously that's a sweeping generalization.
Yeah, no, but it's true. And
Like-
they actually want stuff to be fun. Like, you'll actually retain more employees. It'll be able to recruit people. Like, Dropbox is very good at it. Oh, thank you so much. You've done it. Great.
So actually, like
Nice.
for our happy hours, the people who are like show up and have the most fun are our engineers.
Yeah.
Like they're the ones who are into
love
it.
that.
And all the other jerks from the business side just want to go out and do their own thing. It's
Yeah.
like
Yeah.
so. You're right. It's something that I need to start kind of
Yeah,
focusing on.
it's actually a great thing that you can do. Like,
They don't
you'd be
have to.
surprised.
I'll help them out.
It's like you feel like nobody cares what we do over here. Like, and often like nobody even comes to talk to you when you're an engineer. You're just like sitting at your desk coding away. Like,
Oh, I
hello.
enjoy the shit out of it.
See,
I
that's
come
great.
in, when they see me come in, they're like, "Oh no!" I'm always coming with some stupid like idea that I want to like, because we have a hackathon, so I work together with some of our engineers on just like mini projects.
Oh, that's
Well,
awesome.
mostly what it is just like work really fast on something that we need anyway
Yep, I think that's great though too.
and collaborate. But it's
good.
It's really fun. It's
You're
really
doing a
fun.
good job at your company. All your stuff comes out really nice.
Oh, I
All
appreciate
right,
that. Yeah.
so the next thing I'll do after this is I'll get a few people to come up and share. So like they
Cool.
seem pretty happy to share.
Yeah, and I
which is
mean,
good.
we're good on time, so just take your time.
Yes,
and stuff like
I like prefer it that way.
that. Yeah.
All right, I'll wait like a tiny bit more.
Oh yeah.
Sweet.
How do you so you love working at Gremlin?
Yeah, I really love it. It's funny. I saw the demo and I was like, whoa, this is awesome. It's way better than what we had at Dropbox.
Oh,
like
really?
that was like a mashup of random scripts, Python scripts.
Oh, so you were actually like
Like-
creating your own kind of.
Oh yeah, we made all our own experiments.
Really?
But like the thing is, that's like a really bad way to do it. It's not very safe.
Mhm.
We did have outages caused by it.
Really?
So yeah, like because you have to.
Something's gone bad. Like, that's what
Oh yeah, totally. Like you can definitely, like I never did, but someone else like do it. But it was like fine because I've seen one bad thing in 10 years,
that's like.
and it was like a 5-minute outage, not even a big deal.
Yeah.
Yeah, I've seen way more worse things.
Yeah, I mean, I think at the end of the day, it's just like, because I'm switching to a new role at Catchpoint. I'm
Oh,
doing
okay,
like our
cool.
brand marketing. So
Yeah.
I'm going to be kind of redoing our website and kind of changing some of the messaging that we send.
Ah,
And so I'm looking at the SRE survey that
Yeah,
you
yeah.
took, and it's really interesting to see like the top metrics are availability.
Yeah.
Like, are you up or down? That's at the end of the day, that's
what
what's going to
people
really
care
hurt your
about.
business. Like if you're a bit slower or if things aren't
Yep.
that usability portion,
Yeah.
it's important, obviously.
Yeah.
But at the end of the day, you need to be up and available.
Yep. That's the
in
most
critical
important
times.
thing first.
And it was funny because like when we asked about what are your must-have tool, like what's in your tool bag, what you have to have.
Yep.
The first is like 90% was alerting and notification tools, and then like at 33% was synthetic monitoring.
Yeah.
And so I got like our VCs were like, what the hell, like this is 33%, and like 26% was like APM.
Yeah.
And so like it got me thinking is like these two things are not mutually exclusive.
Yeah.
Like I think people's perception of what synthetic is separate from like their alerting. It's more like
yeah, it is.
How would you alert if you're not collecting data?
Yeah.
Exactly.
And a lot of people
So-
just don't have it either. So that's like the biggest thing I've noticed meeting people. They're like, oh, we don't even have like PagerDuty. We don't imagine page on any alerts. Like, yeah, a lot of people, they manually watch dashboards.
Really?
Yeah.
Yeah, so yeah, that's what I'm because
It's like a
Yeah, I
knock
can
and you're
imagine.
manually looking at the dashboard like, what's down?
Just hire
Yeah,
contractors.
exactly.
Oh, sure.
Yeah.
Really?
Yeah. Yeah.
Interesting.
All right, I'll just do a bit of a walk and check. I'll get you to actually come up and share. So if you want to have a volunteer to come up and speak, that would be awesome. I'll just go around and check and grab you.
Did you guys run
Cool. All right, you're all looking good. Great. Okay. Okay, hey everyone. So now we're going to do some sharing. Sharing time. Oh. Okay. All right. Oh, no, it's actually fun. 1 second. Share. Yes. Okay. So what I might do, because I saw like a few people have their, I'll just go back to here. A few people have their list of top 5 critical services written out. So I might ask you to actually come up and share before we move on to the next part of this exercise. But yeah, who'd like to volunteer to come up and share just so other people can learn? Anybody? Yeah, you want to go first? Okay, and we'll get you to come up as well. And we also have some shirts for you, some bribery. Yeah, that would be great. Yeah, add a bit of color as well. That'd be awesome. Thank you. So this is Gary from Marin Software.
Hi. So our top 5, the first that came to my mind was virtualization infrastructure. We run 3 SaaS sites, one of which is microservice-based. If we were to lose major components of that, large portions of the site would stop functioning. NFS is an easy one to put on the list. We have customers uploading data. Actually, our virtualization infrastructure, all the VMs live on NFS, so losing that would be high impact. The back end for us on this site is Hadoop. So if we were to lose the databases and the job processing, that would be huge. Networking is another gimme. Load balancers, firewalls, things like that. Latency or complete failure of those would stop large portions of the site. And finally, MySQL, we store a large amount of old customer data in MySQL, and any sort of delay would cause an impact to the customer.
Awesome. Thank you so much.
Any questions?
Yeah. Give you a shirt. Cool. Please come up. Yes.
Hi,
So what was your name and where are you from?
Brian Darby. I'm currently a consultant. I did 15 years at National Semiconductor before that. So if 9/11 hadn't happened, the news that week would have been NIMDA. NIMDA brought down IT systems across the entire world. At National, because of to stop the proliferation of NIMDA, we had to disconnect from our own intranet as well as the internet. Then that was kind of a chaos experiment in and of itself, because then we learned, oh, the mainframe is here and the manufacturing guys need the designs to be able to manufacture stuff. So
Anyone else had to do mainframe chaos engineering? Me.
mainframe, which includes database, which is, database is essentially the designs. Then the fact that you're trying to prevent chaos means that your logging and monitoring systems are.
Yeah, that's another really good one.
5. And we've got a guy from here.
Yep.
Security systems. I once designed, I didn't do it, but I designed an attack against our mainframe because the way it was set for security, I could lock out all the users in and out. Think of that. All your users locked out.
And take down your authentication system.
Yep. That's your 5. Thank you very much. And would you like a shirt? We've got one for you up here. Thanks.
All of our sizes right now are baby sizes.
Oh. Oops. We'll bring one this afternoon. Yeah, we're just there. We'll bring more shirts later. Thank you very much. Okay, would you like to share? That's some chaos engineering. We prepared that earlier.
Hi, my name is Pradeep Sayan from Macy. And as a group, what we decided was, what are the 5 things that could go wrong, based on which we can plan our chaos day. So, like the other volunteers were speaking, DB Health is on the top of all our heads. So that's one. I won't explain too much about it. Second one is data replication. If you have multi-site or multi-data center hosted websites or applications, then you will have to worry about replicating data from one site to another site, and replication failures can happen. And how do you deal with that? So that's the next one. Heap thresholds. So for folks who are running Java-based applications, Python-based applications, anything that is heavy on JVM or heap in memory and garbage collection, so that's something that we should worry about. Fourth one's on thread pool. So again, DB Health can go down because your application is not managing your threads properly. Even if you're opening database connections, then you need to basically put it back into the thread pool. That does not happen, then you're going to have problems. And last is load balancer failures. So yes, websites have load balancer failures if the load balancer is not round robining it properly or predicting it properly, then it can send most of your requests to one JVM and bringing it down. So that's my 5.
Thank you. Thanks very much for sharing. And that was Spartan from Macy's. Anyone else like to share? Yep, cool. Thanks. Yeah, it's not often you get to meet other people and learn about what their critical systems are, so it's great to hear. And everyone's are different, which is also interesting.
So I recently changed jobs, but an idea of mine, my previous job, which was at Snapchat.
Yep.
They're hosted mostly in Google Cloud. So their biggest things are database, including data store and Redis, which is where they basically keep everything. And you'll run into a lot of issues with like hotkeys and stuff like that that can basically just cause huge latencies and take down the entire system. They are heavily invested in Google Pub Sub, using lots of queues. And if those queues go down, things like chat messages and other stuff can get lost. A big thing, because we're in Google, is their Interconnect Network. Because they're hosted things like App Engine and GCE are not always in the same data center. So sometimes you're having to go cross-state or even cross-country services. So when those interconnects go down, it makes troubleshooting very difficult to figure out where the issue is. They're hosted a lot in App Engine, and App Engine has some very specific like failure issues, and it's very like a black box, so it's kind of hard to troubleshoot. So building like scenarios around that to kind of figure out how to troubleshoot and produce failures in App Engine is always the interesting one. And finally, a big one with them, because they're hosting Google, is they use Google's deployment service to push all of their code out. So you don't have a lot of ability to write your own health checks and different setups. So you're kind of hoping that their stuff will deploy correctly, but things as far as making sure the thing is coming up healthy, making sure traffic migration and all that is working, we ran into a number of issues with.
Awesome. Thank you so much for sharing. Cool. Thank you. Okay. Anyone else like to share? Okay. Cool. So now we'll move on to the next step. So next thing to talk about in your groups is select one of these services to perform experiments on for your chaos day and explain why you would share that, why you would select that service. So just have a little bit of a think about that. Just pick one. And the idea here is when you do your chaos day, you want to start small. You don't want to do like all 5 services in the one day. Probably not a good idea. Just pick one service. You've just got about 5 minutes. Yeah, just 5 minutes. And explain why you would choose it as well. And then we'll get you to share the reasoning. Cool. Thanks, Eugene. That's interesting. Yeah, that might be great. Yeah. All right, cool. Thanks.
But I mean,
Yeah.
perhaps you can start small with like one level database. Let's say we have a small team, right?
And since you're at school, have you done your major project yet? You're in the middle of what are you building? Yep. Awesome. Yep. Yep. Awesome. That's great. And so then, what might you choose out of that to do your chaos engineering experiment on? Yeah, that's a good one to start with. Often people are scared of doing database chaos engineering, but it's like, well, if you're scared of it, that's a good reason to do it, because then you're going to learn from it. Exactly. If you don't have the database, and he was so true, right, about thread pool. Like this was a really big problem at Dropbox often, just like dealing with thread and it going too high, and then your database gets hot and then it can crash. So yeah, it's like tons of interesting things. Yeah. You can do things like, so we add MySQL. I'll talk about it actually a bit of a diagram, but yeah, you can do things like have a proxy in between the application and the database. You can do that. It's also really important to have a lot of machines, so make sure you have like enough machines. But yeah, and also sometimes you need to actually tell engineers to change the queries that they've written. We also built a distributed data store that sat in between MySQL and the application called Edge Store. So yeah, there's tons of stuff you can do. Yeah, but yeah, it is all Python, which is interesting. Yeah, you can, yeah, which is like what I would always do. Yeah. It's interesting though, because that's how everyone feels, but then it's like, it's more scary if stuff breaks and you don't know how to deal with it. So better to be the one that breaks things on purpose and you're controlling the breakage, and it's also breaking at 11 a.m. instead of 2 a.m. You know what I mean? When you're all there as a team, you can all figure it out together, instead of it's like you're on call by yourself at 2 a.m. and something broke and you're like, ah.
So
that's way scarier.
So for a chaos state, do you have to like alert anyone?
Yeah, you definitely do need to. Yeah, 100%. That's why it's good to even have like an executive there, like a C-level executive, and make sure that everyone knows that it's happening. But I'll talk more about that. I'll do some question time. But we have like a Slack bot that we built. So we have like a chaos engineering channel. It actually posts all the experiments that are running, when they start and they stop, so everyone knows what's going on.
So like you said, you tested in production, right?
Yep.
The users of your system will see that.
So the idea is, when you're doing stuff in production, is you don't want to impact the user. You want to be able to test things to make sure it works, but you don't want to do something so dangerous that it actually impacts users. Yeah.
So your user goes to your site and
Yeah.
it's not.
Yeah, that's why it's better to do that sort of stuff. If you're testing like what happens in graceful degradation, then that's good to do on stage. because you want to actually test it. Otherwise, how do you know if it actually works? But then when you go to production, it's more like if you have a database set up, you want to be able to just like start with killing a replica. What happens then? Which is like less dangerous and shouldn't impact customers. Yeah. Yeah. Cool. Thanks for asking. Alrighty. So who would like to share? Go here. All right. Hi, everyone. Back. So which service did you select for your chaos day? Anyone want to share which one you'd pick? Yep. All right. Awesome. Thank you. Who else? Yeah. Monitoring. Yep. That's a really good one. Monitoring as well. Yep. The database. Yep. Great. Database. Which one would you select? Which service?
Okay, we looked at the services a little bit.
Yep, sure. Yep.
So we looked at customer service claims, which is your open seat cycle.
Yep.
We also looked at sales and marketing.
Yep, perfect. Yeah, that's good.
So when you're looking at those, the number one would be customer service.
Yep, you can definitely do that too, right? What happens if you're using a customer support platform to send all of the tickets to customers and that goes down? Like I've dealt with those outages where I've been called to help resolve those problems. When I was at Dropbox, it happened. It's really a big problem, right? You can have millions of users that are impacted that can't even send in tickets. So it's good to think about those services too. Great. Another one that often gets missed or forgotten, which is very important, is your payments system. So often people forget about that one, but just thinking about the e-commerce flow. So say if people are making a purchase, there are so many parts where that can break. For example, what if you use a third-party API for address validation? Maybe you use Dun & Bradstreet. Maybe you use PayPal. Maybe you use Stripe. Maybe you use Civ Science to like validate if somebody is an abusive person or not. Like they do some machine learning. It's an ex-Google engineers that built it, and they check to see if someone is a criminal, and then they don't allow them to use your system. But yeah, what if that's down? But the thing is, what I've heard from people is they have these payment flows, and they've actually experienced outages because address validation was down, like a third-party service, and nobody could buy anything just because address validation was broken from the third-party service. So very important to think about those things too. I also thought I'd draw you a bit of a diagram to explain database chaos engineering and how you might do that. Who feels like that sounds like a scary idea? Like a lot of people, right? It is a pretty scary idea. But what I like to say is it's more scary when things break at 2 a.m., when you're on call by yourself, when you've been at the company for 3 months, and you're the one that's responsible for fixing it and nobody else is awake, and say like, you know, a large percentage of your customers are impacted. Maybe it's a Sev 0 or a Sev 1 at 2 a.m. that's impacting the database. It's much better to be able to know how to handle these failure modes and these issues by breaking things on purpose, and you can learn a lot through that. But it's also important to think about it like this. You don't do things that harm customers outright. Like that's not what we're about. That's why we say like start small, start with a small blast radius. You don't want to do something that you know is going to impact a customer. You don't want to do something that you know that's going to be bad. You just want to learn more from the exercise. Okay, so I'll just draw you a bit of a diagram. Just get a better text up. Oops. Do we have a better text? I don't know if this one. Maybe this one will work. This one. I'll try this. All right. Okay. So I'm just gonna. Oh, a little hard to see. Okay. Cool. Thanks. All right. All right. That's better. Okay. So this is just one region and then another region. So we have like multi-region. And this is going to be a primary database. And then underneath it has 2 replicas. And then over here we have a pseudo primary and 2 replicas. So this is our pseudo region. And then our primary region. Primary, replica, replica. And let's just say we're using MySQL. That's the platform that we're using for our database, the software. So then we might also say we also have a proxy built in-house, or it could be SQL proxy, open source. And then above this, we also have memcache. For caching, our caching layer. So where do you think might be a good place to start doing your chaos engineering experiment? Memcache, yeah, could be a good place to start. What would be something like less dangerous? Yes, the replicates. And even like way less dangerous, your pseudo replicas, right? So you could actually start by just doing a shutdown of this one replica. And then the things that we expect to happen is that a new replica should be created. So we expect that our automated tooling should kick off a clone. And so the clone should be built. And then we expect that this should then join this cluster. And it should replace the replica that we shut down. So that would be like a very good first chaos engineering experiment. It's not going to impact that cloning works, that it's able to join its cluster again, that all of your monitoring and alerting works for that. Because say if you've got thousands of database machines, you might change how you alert. For example, you probably don't want to alert on sudo primary has one less replica than expected if you've got 6,000 databases. But maybe if you've got a small number, you might want to just be checking that, or maybe you've just built new, just check it. Another thing you can learn from doing this experiment is how long does it take for your clone to actually be created? And that's an interesting thing to think about when you're doing chaos engineering experiments. So you want to think about time to clone. And the interesting thing here is when you run chaos engineering experiments regularly on a schedule, then you can learn a lot of information. So you could learn, is it slower to clone on a Monday morning during peak traffic? Are there some type of networking issues? Or is it really fast to clone on the weekend? Is it fast to clone on a Friday? What happens if we have to do a ton of clones at the same time in this region on a Monday morning during peak traffic? What's going to happen? Then you might go, all right, next we're going to do an experiment where we kill the primary. And then you're going to be testing promotion. So does your replica then become a primary? And does your clone, do you then create another clone? So you again have a primary with two replicas. So that's another good experiment to do next. And then you might, after you've done all these, you've learned a lot from it. The other thing you would want to do too is start collecting those metrics and have them in an actual UI, a platform that everybody can see. This is how long it takes to clone. We've learned a lot about our network. Then you can talk to the network engineers to talk about throttling, all those types of things. You're also going to learn about backups. Say if you have a backup happening, maybe it's coming from the primary or maybe it's coming from the replica. How long does it take for your backup? What happens if you kill a backup? What happens if you need to restore a backup? How long do all of those things take? So this is why like the chaos day is really awesome, because you can actually start to whiteboard just like this and talk to everyone about all of these things and ask all these questions. Because if you ask your team, how long does it take us to do a backup on a Friday morning? Probably no one's going to know, right? How long does it take us to restore a backup on a Monday morning during peak hour traffic if something went really bad and we had to restore from backup? Do we know? Probably not. But this is why chaos engineering can really help you. So that's why I like it a lot. Then when we graduate out of our pseudo region, we might go to our primary region. And then we would actually be doing the same things. So at Dropbox, we would often kill the replica. We might also kill two replicas. And then we would also often go, all right, like we're going to leave our replicas here, have two, make sure they're there, and then we would kill a primary, make sure promotion worked. But you want to be really cautious about how you run these experiments. You don't want to run too many experiments at the same time. That's why it's also very important to have logging for your experiments and have monitoring for your experiments. So we've built all of that into Gremlin. We also have like a Slackbot integration. So we have a chaos engineering channel and it posts every experiment that's running, when it started. You can click to see more logs. You can see when it's successfully finished. All of those things are very important too for that. And then when we go, all right, like let's look at proxies. What happens if we kill one proxy or kill multiple proxies? Does that cause any impact? How long does it take for the proxy to be recreated? What about memcache? What happens if we kill a memcache instance? Is everything all right? How long does it take for that to be recreated? So these are all awesome things that you're going to learn about when you do chaos engineering, and that's why I've done it myself, and I've got those 10x reductions. You can easily see that you're going to collect so much data that it actually enables you to then take that data and go and talk to all the different teams that you need to talk to, because you've got real evidence that shows, hey, like networking team, I need you to prioritize working with me to fix our backups because of these reasons. Like if we actually had to use our backup, it's going to be really tough. It's going to take a long time. Can you help me figure out how to make that much better? Cool. Yeah.
I have 2 questions.
Yeah, go ahead.
So the first one, losing the primary.
Yep.
Measure of success that the replica takes over, and then it also detects now I'm down a replica, and it autonomously creates the replica.
Yeah, exactly. So in Dropbox, there's automated remediation tooling or self-healing tooling, which is what it's called in academic world. And that tooling is built in-house. But recently, there's actually a company that created this tooling. They're called Rundeck, and it's open source. That looks pretty interesting. I haven't tried it yet. Anyone tried it?
Well, that's actually just a basic
okay.
for automating.
So it is pretty, it's not anything, oh, okay, interesting. All right, yeah, so I have to look at that. But the idea with, yep.
With Amazon,
yep.
we typically create auto-scaling groups.
Yeah, you can do that too. So yeah, with, if you're using Amazon and you have, say, Amazon RDS, they automatically will handle all of the replication for you and the promotions. If you use like Amazon RDS MySQL. But then there, you want to make sure that it actually works, right? Like you want to check that it does function as you expect it. You want to make sure that your monitoring and alerting is appropriate. So like I know Eugene and Ho Ming can attest to this. They worked at Amazon. They know the inside story. But yeah.
So losing in your first example, we
yep.
lost the replica.
Yep. Yes.
In my infrastructure, I would
yep.
detect it,
yep.
but we don't have anything.
Oh, you don't have automation yet. All right. So
how many
it's very good. Yeah.
Have gone to that next step.
Yeah. I'm a fan of automated self-healing systems because if you don't build that tooling, then it means that you're going to have to manually page somebody. They're going to have to do the promotion. They're going to have to kick off the clone. So I really do think that it's much better because there's so much human error that can occur in that situation. I still think you should have your database experts working in your team, your database engineers, but if they don't have to handle that manual work, then they can focus on other things like database performance, making sure that your application is really, really fast and amazing. And they just ended up focusing on other things. And I know it's not easy tooling to build, right? It's going to take time, but then you can also use this chaos day and this whole initiative as a reason for why you need to hire engineers or why you need to get budget to be able to kick off this project. Yeah.
And what you're saying is it's mostly self-written stuff. There's not a lot of good open source.
Not yet. No. There is one tool called Orchestrator, which was created by Shlomi. He's now at GitHub, and I think that's quite promising. There's a lot of interesting tools that you can see around self-healing systems, but it is a pretty new area. Who here is confident or has like very good self-healing systems? A few people, so it's like pretty new. Yeah, but it's a good thing to do when you're focusing on your database, but you don't have to have self-healing systems as a prerequisite for chaos engineering. Like I wouldn't say that at all. Yeah. Yeah. Exactly. Exactly. Like at Dropbox, this infrastructure is 6,000 machines and one database engineer on call. Like I was, for example, on call from 3 p.m. to 7 p.m. every day because like pretty much never got a page. But I was always on call every day just in case something went wrong. And the thing there is at Dropbox, there is promotion tooling that is built. If promotion fails, there's emergency promotion tooling. So there's like backups on backups of the self-healing tooling, which I think is also important. But yeah, all of those tools are tested using chaos engineering. Yeah.
So in your tendency list, you got like data engineering.
Yeah.
To principal engineers.
Yep.
So you didn't have like a DBA or engineers or system engineers.
Yeah, and I think like that's a really good idea. So the idea is I would say like if you want to have a database engineer, like have your very senior database staff engineer or principal engineer or something like that. If you have someone at your company, But you definitely want to have someone to represent the service that you're going to be focusing on for the chaos day. That's really important. Yeah, I would definitely say that. So if you're going to say, let's focus on our Hadoop infrastructure for our chaos day, let's make sure you have an engineer from that team there. If you're going to focus on database, make sure you have an engineer there. So that's why I had that one engineer. Yeah. Yep.
So if you don't have this other tooling infrastructure,
yep,
doesn't mean that you should not try chaos day.
You should still do it, because what happens if like you don't do a chaos day and someone gets paged at 2 a.m. and then they have to manually do a clone? But you don't want to kill too much stuff. Like that's this idea of blast radius. So if you just want to be take small steps, like baby steps. Just kill one replica first, I would say, is a good thing to do, right? What happens if a replica fails? And you want to be able to then see how long does it take our team to be able to create a new replica? Because that's the thing too. If you don't have the automated tooling, they probably have scripts. And it's a good chance for you to see what they do. And then you can also time it. So you can be like, all right, if we lose a replica, how long does it take us to then create a new replica? It might take them an hour, it might take them 20 minutes. It really depends on how good the tooling is. But the other thing too is if they know that a chaos day is coming in 90 days and they know that you're going to be focused on doing experiments on that team, they're probably going to try and build some better tooling and improve it and make their scripts better, because they know that everyone's going to be looking at that to see how it actually works. So yeah, you can see here that chaos engineering is a really great incentive for building better tooling, being more efficient, focusing on reliability. Whereas when you think of something like a hack day or a hack week, it's all about building features. Chaos day is all about building more resilient systems.
Yeah, I mean, looking at that, I would say 90 days. Really good timeline.
Yeah, 90 days, totally. I think so as well. I first was like 60 days. No, too short.
Doing experiments that you really aren't sure what's going to happen.
Yep.
I mean, should this be like when you're, they say a lawyer should only ask the questions and only answer?
Yeah, I think that's a great question for Eugene. Yeah.
I would say you always want to tie it to a goal and you get better at it, right? Like if your VM's Ethernet device was integrated, what usually happens? Or would it never run away from that process? Probably wouldn't be something like, for some reason I'm just gonna delay stuff for a year. Like have Fox do for a year. And when you're actually testing, I want to see if my service recycling functions work. So that kind of server expiration, that's going to refresh. So you always want to tie experiment to some high level description of the event that's gonna happen.
Yeah. Any other questions?
I've got a question for you, Mark.
Yeah, sure.
So a lot of focus is on testing your systems, but how about testing the people on your team?
Yep,
I know
totally.
Google does randomized testing to make sure that their engineers are ready.
Yep.
So how do you balance that? Is it a way that, the method?
Yep, great question. So I definitely think that chaos engineering is very, very good on-call training. That's one thing that you'll find out. It's really going to help you. And like who here does on-call training? Like nobody, right? Oh, one person, that's awesome. Like usually this is not common. On-call training doesn't really happen. I did it a lot at Dropbox. I also did it at DigitalOcean. We did it at the National Australia Bank. I've done it everywhere. And for me, it's super important. I like to do a few different types of on-call training. One is look back at your previous incidents, like not the high major outages, just incidents, things that happen where someone needs to manually do some sort of action to get things back to a good steady state. Take those top 5 things that most commonly happen. You can actually pull your PagerDuty data for the incidents and look at the most common issues where someone got paged and had to do some type of action before they could resolve it. And then actually you can use a chaos day to go through those incidents. So actually use those as your chaos engineering experiments. Hey, like notice for us, one of the ones at Dropbox was we didn't have very good automation around proxies, like being popped back up again when one was killed, because we had so many. We're like, oh, if one gets killed, it's okay, like we've got so many. But then we actually were like, oh, it's actually pretty annoying when someone gets paged, that's manually make sure there's another proxy. So we then run through that during a chaos day and made sure to actually prioritize building better proxy automation tooling, which we actually did. So that was quite good. The other thing for on-call training is Who here does SEV reviews or like incident reviews, postmortems? Like most people would do those, right? So if you write a postmortem or a SEV review, I like to call them SEV reviews, then one of the things in that is your action items at the end of this. Like, what are the things that we need to do to make sure that this never happens again? That's like always my question. Like, how do we make this SEV never happen again, especially if it was a SEV 0 or a SEV 1? And one of the things you do there is you put in action items. We need to build this, we need to do this, we need to fix this alerting, we need to have better monitoring for this, we need to do on-call training. One of the very good things to do there is to say, we need to actually run these chaos engineering experiments because we're going to reproduce this SEV. So after we've done all of those action items, we've put in all of those fixes, you then actually reproduce the SEV. You make it happen again, and you prove to everybody that, yeah, this did happen again, and we were fine. That's a really good thing to prioritize, especially for SEV zeros. I was on call for the S3 outage, you know, the really big one where it was like, I was there in my seat for 5 hours as the incident manager on call for all of Dropbox, just like, whoa, madly typing away for 5 hours straight. That was a long day. But during that SEV, we actually put together some steps, some action items of things that we needed to fix after that SEV. We did them, and we made sure that we were not going to be impacted again. And then we did reproduce that S3 outage. You can do it within Gremlin. It's like a few clicks to reproduce that outage. Eugene and Homing often show everybody. And the cool thing there is, like, during the outage, thumbnails and previews didn't work for Dropbox, so that was bad. But then because we did the action work, we then reproduced the outage. We were able to show, like, if it happens again, we're fine. And I think that is a really good way to show people the value of chaos engineering. Yeah, yeah.
Is your service provide, like, so our application rely a lot on several calls, web services?
Yeah.
Several meetings?
Yep. Internally or externally? Externally, so third-party services, Eugene? Yeah. Yep. Yep. Yeah. It's such an important thing to do. And often we just don't test that. Like, we don't go, hey, like, what happens if that third-party service goes down? I really need this service to work. Yep. Yeah, we often talk about that one too. Awesome. All right. Okay. So thank you so much from us. I just wanted to share 2 more things as well. One is we're actually doing a chaos engineering conference, and we have a call for papers open right now. So if you'd like to do chaos engineering, if you're a newbie, that's totally cool, right? Start to do some chaos engineering now, and then you could share your story at the end of the year in September at our Chaos Conf conference. So that's a great thing. We have a Slack where you can meet other engineers who are practicing chaos engineering. There's over 600 engineers in there. So if you go to gremlin.com/Slack, you can join our Slack. And yeah, come chat to us at lunch. Thank you so much.